Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My dear students, once again we are together. I am Professor Asif Qureshi, working as Assistant Professor of Chemistry at Govt Biology College, Qasimabad, Hyderabad. Today I am with you with a new lecture of the series of the same chapter, same topic. Chapter number 3, the atomic structure. Topic is once again electronic configuration. And today is the third and the last part of this particular topic, electronic configuration. About this topic we have already gone through two lectures. Part 1 of this lecture was based upon the first principle, which was the Hund principle, and part 2 of the same lecture was based upon the Hund's rule, which we have already discussed. Again, for your memories, recall and refresh your memories. Electronic configuration is the process by which the electrons are distributed or added among various subshells of an atom is called electronic configuration. These are 4 basic rules or principles for building up the electronic configuration of an atom. Our principle, we have already discussed it in part 1, the first lecture. Hund's rule, we discussed this rule in the part 2, second part of the lecture. Now today's lecture is based upon these 2 rules, and inshallah we are going to complete these 2 principles, these 2 rules in today's lecture. The third rule is the N plus L rule, which is also called Vis-Viscer's rule, while the fourth and the last one is Pauli's exclusion principle. So my dear students, our today's lecture will cover these 2 rules or principles for the electronic configuration of elements: N plus L rule or Vis-Viscer's rule and Pauli's exclusion principle. Now the third rule for the electronic configuration of elements we are going to discuss today is the N plus L rule, or it is also sometimes called as Vis-Viscer's rule, based upon the name of the scientist who gave this rule. Dear students, this rule was given by the man named Vis-Viscer. So this rule is called Vis-Viscer's rule also. Here N represents the principal quantum number, while L represents the azimuthal quantum number. So in this rule, N plus L rule or Vis-Viscer's rule, N is the symbol used for the principal quantum number, while L is the symbol used for azimuthal quantum number. The statement of the rule says now this is the complete statement of the rule. The statement of the rule says whenever you are building the electronic configuration of the atom, the orbital having lower n plus n value value fills first. If two or more orbitals have same n plus n value, then the orbital having lower n value fills first. Now if I am going to illustrate this statement, if I want to explain this statement to you, I must tell you that the Afba principle, order of filling of electron, according to Afba principle, was entirely based upon this n plus n rule. If you recall your memories, the order of filling electrons which we did was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and so on. This was the order of filling electrons. Filling electrons according to Afba principle. This we have already discussed in the first part of the series of lectures of the electronic configuration series. Now I must tell you here that this order is fully justified and it is based upon this particular rule, n plus n rule. Now try to understand what I am going to say. First, the two electrons were filled in the 1s orbital. Why? Two electrons entered in the 1s orbital because for 1s orbital the value of principal quantum number is 1, while for s orbital azimuthal quantum number is taken as 0. So 1 plus 0 makes the sum of n plus n value as 1, which is the lowest value. So for lowest n plus n value, first two electrons were given to 1s orbital. Then after two electrons were added to the 2s orbital. Why we fill two electrons to the 2s orbital? Because for 2s orbital the principal quantum number value is 2, while azimuthal quantum number value is again 0. So 2 plus 0 makes the sum of n plus n value as 2 now. So after 1s orbital, 2s orbital was filled with 2 electrons. Then 2p6 was the order of filling electrons. means 6 electrons were added to the 2p orbital. Why? Because for 2p orbital, again the value of n is 2, while for p subshell and L value is the 1. So sum of n plus L value for 2p orbital becomes 3 now. So after 1s, 2s, 6 electrons goes to the 2p orbitals. Then after 2 electrons were allowed to enter in the 3s orbital. Why it was 3s? Because for 3s orbital the principal quantum number value is taken 3, while for s subshell azimuthal quantum number value is again taken 0. So again the n plus L value for 3s orbital becomes 3. Now according to the definition, you will look into this, that 2p and 3s orbitals have same n plus L value. They both have same n plus L value. 3 is the n plus L value for 2p orbital, 3 is again the n plus L value for 3s orbital, but the n value is lower for 2p. So first 6 electrons were entered into 2p orbital, then the n value was 3, which is higher than 2. So again 2 electrons were entered into 3s orbital after filling 6 electrons in the 2p orbital. So this is the justification of the statement. Proceeding further, 3p got 6 electrons because the n value for 3p is 3. L value is 1, so sum of these two values becomes 4 now. 4s, 4 is the n value for s orbital, 0 is the L value. So again the n plus L value becomes equal for these two orbitals, same n plus L value again. But the lower n value is for 3p orbital. So first 6 electrons are allowed to enter in 3p. Then the higher value of n is for 4s. So then after filling 3p, we got 2 electrons in the 4s orbital. Now 3d got 10 electrons. Why it has got 10 electrons? Because for 3d the n value is 3. For d orbital L value becomes 2. The sum of n plus L value becomes 5. After 4, 5 is the higher value. So after 4s, 3d orbital was filled with 10 electrons. Then 4p, 6. 4 is the n value. 1 is the L value for p subshell. Again it becomes 5. And after 4p, 6, it will be 5s2. 5 will be the n value. 0 will be the L value. Again n plus L value for these 3 orbitals become same. But as you all know that lowest n value is for 3d. So first 10 electrons were allowed to enter in 3d orbital. Then the higher value of n is for 4p. So 6 electrons go to 4p orbital, and the highest value of 5s make it after 3p and 4p. It will be allowed to get 2 electrons. So this is the sequence of filling the electrons in the respective orbitals according to n plus L rule, and this whole covers the Aufbau principle as well. This is the first rule which we have discussed in today's lecture. Dear students, this is the fourth and the last principle or rule for the electronic configuration of elements. This is called Pauli's exclusion principle. As the name indicates, that the principle was given by a man named Wolfgang Pauli, and the year in which he gave this principle was 1925. The statement of the rule says that in an atom, no two electrons can have the same set of 4 quantum numbers. Means in a single atom, in the same atom, two electrons cannot have the same values of all the 4 quantum numbers. If I want to explain this statement, I say in an atom, two electrons may have maximum number of 3 same quantum number values, while the fourth would be different. Means for two electrons, principal quantum number may be same. If they have same principal quantum number value, means they can have their place in the same orbit shell. If their azimuthal quantum number value is same, means in the same shell, they may be in the same subshell as well. If their magnetic quantum number value is same, means same shell, same subshell, same axis they will be having together. But always remember that their S value, spin quantum number value will always be different. If one electron have the spin quantum number value of plus half, the other would be definitely minus half. Means their spin would be opposite or paired spin. One electron shows the clockwise spin, while the other electron will show anti-clockwise spin. So for two electrons, maximum number of 3 quantum numbers values will be same, while the fourth will be different always. So this was the fourth and the easiest principle called Pauli's exclusion principle. Dear students, the topic was very important. Many important things always come in your board exams or your MDCAT MCQ paper. So I tried my level best to cover this topic in detail, and that's why I got this topic completed in 3 parts. First part was based upon Afbah principle. Second part was fully based upon Hund's rule, which I explained in detail, and today I have covered these 2 rules, N plus L rule and Pauli's exclusion principle. So that's enough for today's lecture. Inshallah, in my upcoming lecture, I will be with you with a very important topic again from an important chapter. So till then, Allah Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.